Everyone, today we are about to begin our PowerPoint presentation containing the assigned topic for our group, which is all about wind power. But before that, may I introduce myself? I am Joey Rose Prado, together with my group mates, Joanna Sagon, Julius Faustino, Jerica Pearl Poilong, Giselle Joy Casula, and last but not the least is Jetler Alice. Now, may I begin to you with reading our objectives for this lesson, for this presentation? At the end of the lesson, students should be able to first know what is wind power, second, know the history of wind power, third, know the types of wind power, fourth, know how does wind power works, five, identify the two types of wind turbine, and lastly, know the advantages and disadvantages of wind power. What is wind power? But before that, what is wind? So, a short definition for what is wind is the movement of the air. And wind is produced in three ways. So, first, wind is produced naturally when the sun hits the atmosphere. Second, wind is produced from variation in the surface of the earth. And third, wind is produced from the planet's rotation. Wind can then increase or decrease as a result of the influence of bodies of water, forests, meadows, and other vegetation and elevation changes. Wind patterns and speed vary significantly across terrain as well as seasonally. But some of those wind patterns, are predictable enough to plan around. That's why we have this called renewable source called wind energy or wind power. What is wind power? Wind power or wind energy describes the process by which the wind is used to generate mechanical power or electricity. Wind power is a form of energy conversion in which turbines, which is to be tackled later on, convert the kinetic energy of wind into mechanical or electrical energy that can be used for power. Wind power is considered a renewable energy source. Historically, wind power in the form of windmills has been used for centuries for such tasks as grinding grain or pumping water. So keep in mind that the main goal of wind energy is to create sustainable forms of energy. Wind energy is electricity created from the naturally flowing air in the Earth's atmosphere, as I said earlier. As a renewable resource that won't get depleted through use, its impact on the environment and climate crisis is significantly smaller than burning fossil fuels. Generating energy from the wind does not release any carbon emissions. By replacing electricity generated from other sources such as fossil fuel power stations, wind energy can lead to an overall reduction in carbon emission. And then, it is very clean energy source. Wind is a very clean energy source which does not release any pollution or produce any waste during operation. That's why wind power is one of the fastest growing renewable energy technology. And usage is on the rise worldwide because in part costs are falling. Talk about the history of wind power. The history of mankind's use of the wind as an energy source is surprisingly long. In fact, it could be classified as one of the humanity's oldest power sources. To trace wind back to its ultimate roots, we need to go back in time beyond the dawn of recorded history. Nobody really knows when the wind was first harnessed by human being, but wind was definitely being utilized as a way to move boats on Egypt's Nile River around the year 5000 BC. By 200 BC, people in China were using the wind to power simple water pumps, and windmills with hand-woven blades were used to grind grain in the Middle East. Over time, wind pumps and mills were used in all kinds of food production there. And the concept then spread to Europe, where the Dutch built large wind pumps to drain wetlands, and from there the idea traveled to the Americas. American colonies hewn windmills to grain, to pump water, and to cut wood at sawmills. Homesteaders and ranchers installed thousands of wind pumps as they settled the western United States. In the late 1800s and early 1900s, small wind electric generators or wind turbines were also widely used. The number of wind pumps and wind turbines declined as rural electrification programs in the 1930s extended power lines to most farms and ranches across the country. However, some ranches still use wind pumps to supply water for livestock. Small wind turbines are becoming more common again, mainly to supply electricity in remote and rural areas. So, wind power has been used as long as humans have put sails into the wind. For more than 2 millennia, wind power machines have ground grain and pumped water. Wind power was widely available and not confined to the banks of fast-flowing streams or later require sources of fuel. So that's why it is one of the oldest power sources. So next to this is a short video presentation to enlighten you more about wind power.
Hi, I'm Lee Patrick Sullivan with Energy Now, and today I would like to talk to you about the power of the wind. People have been using wind as a form of energy for thousands of years to power sailboats and windmills. Without the power of wind, our ancestors would have struggled to travel across oceans, trade with other nations, and explore the wonders of the world. Wind is air in motion. It's caused by uneven temperatures on the Earth's surface when heated by the sun. Because the air over the land heats up more quickly than the air over the water, the warm air rises and the heavier, cooler air rushes in to take its place, creating wind. While this process is not as predictable as the rising and setting of the sun, it's just as renewable. In 2010, wind power generated about 2% of total U.S. electricity. Wind turbines harness the kinetic energy of moving air. The air blows over the blades, creating lift just like the wings of an airplane. This causes the blades to move, and through a drive shaft, this turns a generator that creates electricity. Similar to solar arrays, wind farms connect individual wind turbines together to generate electricity on a large scale. These wind farms can be built on both land and water. Building wind farms off the coastline of the United States is a new idea for capturing more of the wind's energy. Offshore areas have plenty of space, the wind is reliable, and wind farms built off the coastline would be much closer to major cities than those that already exist on land. The first offshore wind farm to win a permit from the federal government is scheduled to be built off the shore of Cape Cod, Massachusetts. Current plans call for 130 wind turbines, or enough to power hundreds of thousands of homes.
You learned something from that short video, and now let's have Mr. Faustino to explain to us the three major types of wind energy.
Hello everyone, I am Julius M. Faustino. At this moment, I am going to report about the types of energy. There are three types of energy. The first one is utility scale wind energy. This is a large-scale wind project designed to be used as source of energy to a utility company. These large turbines have rotors measuring more than 250 feet in a diameter and are installed on tall towers that require aviation, obstruction notification, and lighting. Because of this size and this scale of this installation, utility-scale wind turbines require environmental utility and public coordination at this highest level. Utility-scale wind farms require exciting resources, assessments, legal and financial due diligence, utility integration, and financing typically of a very large capital investment installation such as a. And the second one is offshore wind energy. These are generally utility-scale wind energy projects that are planned in water of coastal areas. Offshore wind is a abundant domestic energy resource that is located close to major coastal load centers. It provides an efficient alternative to long-distance transmission or development of electricity generation in land-constrained regions. And the last one is small-scale distribution wind energy. This type of wind energy is the opposite of example above. These turbines, however, typically require less maintenance than larger machine. This class of machines can cost as much as house and is the smallest project size that might be financed, which would require a land review project of this size may also trigger the need for consent resources assessment. But often project can move forward by using nearby measurements and experience sheeting and project modeling.
So, as summary for Sir Faustino's explanation about the three major parts of wind energy, utility scale wind energy or turbines are usually defined as turbines that exceed 100 kilowatts in size. Utility scale wind turbines are typically installed in large multi-turbine wind farms connected to the nation's transmission system. Then the next one is offshore wind energy or turbine. Wind turbines that are erected in large bodies of water. These are generally larger than onshore turbines, and because the larger the turbine, the greater the efficiency, so that they are able to generate more power. The third one is small wind energy or distributed wind energy. This applies to wind turbines below 100 kilowatts that are used to directly power a home, farm, or small business that is not connected to the grid.
So, how does wind power works? Wind energy is energy obtained from the force of the wind. How through wind turbine that transform the kinetic energy of air currents into electric energy. This is a transform into electric energy using wind turbines or wind energy conversion system. Wind first the turbines blades causing them to rotate and turn turbine connected to them that change the kinetic energy to rotational energy by moving a shaft which connected to a generator and they there be producing electricity energy through electromagnetic. And we are talking about a renewable, efficient, nature and secure energy that is key to the energy transition and the deconstruction of the economy. If the wind energy is used directly as a mechanical force like milling grain or pumping water, it's called a windmill. If it converts wind energy to electricity, it's known as a wind turbine. Wind turbines works on a simple principle. Instead of using electricity to make wind like a fan, wind turbines use wind to make electricity. Wind turns to a properly like blades or turbine around a rotor, which spins a generator which creates electricity.
Now let's have Miss Sagon to define to us what is a wind turbine and its schematic system.
I'm gonna talk about wind turbine. A wind turbine turns wind energy into electricity using the aerodynamic force for the rotor blades, which work like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade and creates both lift and drag. The force of the lift is stronger than the drag, and this causes the rotor to spin. The rotor connects to the generator either directly if it's a direct drive turbine or through a shaft and a series of gears or a gearbox that speed up the rotation and allows for a physically smaller generator. And this translation of aerodynamic force to rotation of a generator creates electricity. So, basically, ang wind turbine, hindi siya sang windmill, kasi ang windmill ga-generate lang siya sang mechanical, not electrical. So wind turbines are rotating machines that can be used to generate electricity from the kinetic power of the wind. And this wind rotates the turbine blades, and these turbine blades spins a shaft connected to a generator. So each of the turbines that make up a wind farm are linked together by underground cables that carry the electricity to a transformer substation. From there, it is transported to homes, factories, or schools among other recipients through the distribution network of the various electricity. So most of the typical wind turbines being used today are horizontal one, and the two types of wind turbines, which is the horizontal one and the vertical. And the basic components of any wind energy system are fairly similar. There are blades of some size and shape that are connected to a drive shaft, and then a pump or generator that either uses or collects. And the wind energy is used directly as a mechanical force like milling grain or pumping water, and it's called a windmill. If it converts wind energy to electricity, it's called a wind turbine. So a turbine system requires additional components such as a battery for electricity storage, or it may be connected to a power distribution system like power lines. So here's a schematic diagram of the wind turbine system. So first, the wind direction, it determines the design of the turbine. The upwind turbine, like the one shown here, it faces into the wind while downwind turbines face away. And the blades, it lifts and rotates when wind is blown over them, causing the rotor to spin. And most turbines have either 2 or 3 blades. And then the generator, it produces 60 cycle AC electricity. It is usually an off-the-shelf induction generator. And then the anemometer, it measures the wind speed and transmits wind speed data to the controller. And then the gearbox, which is really important to increase the rotation speed. And then the wind vane, it measures wind direction and communicates with the yaw drive to orient the turbine properly with respect to the wind. And then the high-speed shaft, it drives the generator. And then the yaw drive, it orients upwind turbines to keep them facing the wind when the direction changes, and downwind turbines don't require yaw drive because the wind manually blows the rotor away from it. And the nozzle, it sits atop the tower and it contains the gearbox, low and high-speed shafts, the generator, controller, and brake. And some nozzles are large enough for a helicopter to land on. And then the low-speed shaft, it turns the low-speed shaft at about 30 to 60 rotation per minute. And then also the brake, it stops the rotor mechanically, electrically, or hydraulically in emergencies. And then, of course, the tower, which supports the whole structure of the turbine because wind speed increases with height. Taller towers enable turbines capture more energy and generate more electricity. And then the controller, it starts up the machine at wind speeds of about 8 to 16 miles per hour and shuts off the machine at about 55 miles per hour, and turbines do not operate at wind speed at about 55 miles per hour because they may be damaged by through winds. And then the rotor, and then this is the last, the rotor, which is the blade and hub.
The beginning of wind turbine. The first known wind turbine was said to have been built in Scotland, UK, created by Professor James Blyth of Anderson's College in Glasgow, now Strathclyde University. This turbine measured 10 meters high and was originally installed in the garden of Blyth's holiday home. As you can see in the picture, that's the wind turbine that Professor James Blyth created. Wind turbine have two types. The horizontal axis wind turbine or hot and vertical axis wind turbine or VOT. Horizontal axis wind turbines are the most common. The rotating component are horizontal to the ground, yielding the propeller-like blades on towers usually found on wind farms. The turbine nose must be facing the wind for there to be any spin, so wind vanes and yaw systems are built in to turn the system towards the wind. Hot is a wind turbine in which the axis of the rotor's rotation is parallel to the wind stream and the ground. All grid-connected commercial turbines today are built with a propeller-type rotor on a horizontal axis. Horizontal axis wind turbine dominate the majority of the wind industry. Horizontal axis means the rotating axis of the wind turbine is horizontal or parallel with the ground. HOT typically has a three-blade vertical propeller that catches the wind face on. It looks like an airplane propeller. The horizontal axis turbine need the wind to flow at the right angle to the blades. If it blows from a different direction than the blades are facing, the turbine gets much less energy from the wind. To accommodate changes in wind direction, the turbine has a yaw drive that rotates the unit's direction. However, the drive adapts slowly in changing directions because it must turn the entire turbine and propeller assembly. The next is the vertical axis wind turbine or VOT. Although output is lower and the lower height means wind speeds are generally lower, it offers easier access to mechanical parts. Wind from any direction moves the turbine, and the vertical axis enables the blades, spinning horizontally to the ground, to move when the wind blows from any direction. They also perform well in extremely high wind, although are less efficient than horizontal systems. In comes the vertical axis wind turbine. The rotational axis of the turbine stands vertical or perpendicular to the ground. It has a set of blades that spins around a vertical axis. It looks like a giant egg beater. Vertical axis turbines are powered by wind coming from all 360 degrees, and even some turbines are powered when the wind blows from top to bottom. VOT runs well regardless of wind direction, making it better suited to urban areas with tall buildings where wind turbulence is given. The vertical axis turbine allows it to operate on lower wind speeds than is possible with the horizontal turbine.
So means that in a horizontal axis wind turbine, a vertical propeller spins facing the wind horizontally, while in a vertical axis wind turbine, blades spin around a vertical axis facing the wind vertically. So thank you, Miss Kasula. Now let's have Miss Poilong to explain to us wind farms. Wind farm. A wind farm is a cluster of wind turbines erected in areas where there is a nearly steady prevalent wind. Such areas generally occur near mountain passes. Wind farms comprising propeller-type unit have been set up in Hawaii, California, and New Hampshire. Capacities range from 10 to 500 kilowatts per unit. The process involved in building a wind farm is very complex since there are many characteristics that must be analyzed to know where and when it should be built. Of this, the most important characteristic that must be analyzed are the spatial, temporal, and vertical variation of wind through time. These parameters are studied with wind vanes and anemometers, and the future production of wind farm is estimated to guarantee its potential efficiency. Cutting-edge supercomputing technique optimize the design of the wind farm complex to maximize the generation of energy. During 1984, the total output of all U.S. wind farms exceeded 150 million kilowatts-hour. The entire output was fed into the electricity utility network. Though seemingly substantial, this amount to less than 1 over 100,000 of the total electric power generated in United States. So, knowing the location and height of turbines create a better understanding of radar wind issues and increase the effectiveness of planning both new radar and new wind turbine locations. The best place for wind farm are in coastal areas at the top of the rounded hills, open plains, and gaps in mountain places where the wind is strong and reliable. There is no official number requirement for an installation to be considered a wind farm, so it could be include a few more hundreds of wind turbines working in the same area, whether on land or offshore.
Wind farm can be based onshore, on land, or offshore sea or freshwater, with key difference between the two. Traditionally, onshore wind turbines solely dominated the market until the first offshore wind turbine was installed in 1991 off of the coast of Denmark, and installed more than 1,200 offshore wind turbines. Onshore wind power refers to turbines that are located on land and use wind to generate electricity. They are generally located in areas where there is a low conservation or habitat value. Offshore wind power is when wind over open water, typically the ocean, is used to generate electricity. The electricity generated by the turbines at the offshore wind farm is then sent to a single offshore substation. Once ashore, the energy processed at the onshore substation and put into the public grid, ready to power the lives of millions of people. Overall, wind turbines, regardless of their location, onshore versus offshore, are quick to install, especially when compared to other energy sources. Having proven itself as the key player in providing energy to the public, wind energy will continue to be an integral part of the energy conversation for as long as the wind blows. Wind power becomes an increasingly popular renewable energy source. Researchers anticipate significant improvements in both onshore and offshore wind technology. When deciding between onshore or offshore wind, there are many variables as to which type of wind farm is chosen by energy suppliers, including political, financial, and geographical factors. Generally, whether one of the other is used is assessed on a case-by-case basis. But what is clear is that wind power is increasing in popularity around the world as the technology becomes more financially sustainable and global policies and target the climate change are created. The world's biggest wind farm, with a planned installed capacity of 20 gigawatts, also known as Gansu Wind Farm, it will feature 7,000 wind turbines installed across Sichuan, Inner Mongolia, Hebei, Xinjiang, Jiangsu, and Shandong province of Gansu, China. Because of some part of the country population suffer persistent electricity shortage, China State Council is pushing for an all-around renewable energy strategy to reduce the country's reliance on finite resources like oil, coal, and gas for 20th century. The construction of Gansu Wind Farm will cost nearly $20 billion. Burgos Wind Farm, Ilocos Norte, Philippines. The 150 megawatts Burgos Wind Farm is the largest wind power project in Southeast Asia and is located within a 600-hectare site. The facility consists of 50 wind turbines, each with capacity of 3 megawatts, generating electricity to the Luzon grid. The project also includes a substation and a 43-kilometer long 115 kV transmission line, and completed on November 9, 2014, making it the country and the Southeast Asia largest wind farm. But mula na siya ning only in Luzon, di na siya makaabot diri sa aton sa Mindanao kay limited lang man ang makaya niya. That's all. Thank you.
Thank you for an explicit explanation about the wind farms, Miss Poilong. Now let's have Mr. Alice to explain to us the pros and cons of wind power. Mr. Alice?
Let's talk about the advantages and disadvantages of using wind power as a source of energy. But first, let's talk about the advantages. So first advantages of using wind power as a source of energy is wind power is renewable and clean because wind is provided by the rotation of the earth in heat from the sun, meaning that unlike non-renewable form of energy, we will never run out of it. Wind energy also doesn't pollute air, unlike the fossil fuels that release harmful particles in the air that have been shown to have negative effects on human health and environment. As long as the sun continues to shine and the wind blows, we can utilize the wind energy to power our lives. Second advantage of using wind power as a source of energy is wind energy has low operating costs. So as far as upfront costs go, wind farms or individual turbines can be expensive to install. However, once up and running, operating costs are relatively low, their fuel or wind is free, and the turbines don't require too much maintenance over the course of their lifetime. Advantage, wind energy is space efficient. So it means qualitatively, wind farms can take up a lot of land space. However, the actual turbines and equipment don't use up a lot of real estate. This means that land used for wind turbines can also often as used for other purposes such as farming. So fourth advantages, wind turbines can be built on existing farm or ranches. It means it is greatly benefits the economy in rural areas where most of the best wind sites are found. Farmers and ranchers can continue to work the land because the wind turbines use only a fraction of the land. Wind power plant owners make rent payments to the farmer or rancher for the use of the land, providing landowners with additional income. So fifth advantage is reduces our dependence on fossil fuels. So energy generated from fossil fuels not only contributes to climate change but will one day run out of it. So as long as the sun hits the planet and there's an endless supply of wind. So furthermore, developing and investing in technology that can only run on a finite source that we may run out of our lifetime is a terrible waste of human capital, private funds, and tax dollars. Number 6 advantage is low operational cost. So in general, once erected in commission, wind turbine require little in the way of maintenance. So the technology might be sophisticated, but the mechanics are straightforward and reliable. Number 7 advantage is job creation. So wind energy production is a fast-growing industry and more jobs are being created to service it. So design, manufacture, installation, maintenance, and support mean that is estimated that some 600,000 jobs will have been created by 2050. Already more than 100,000 people are employed in wind power production in the US. So the last advantage of using wind power as a source of energy is prices are decreasing. As technology improves, so electricity produced by wind production gets cheaper. The last 40 years have been price tumble and while may not continue at the same rate, so the trend is downward for a foreseeable future. Let's move on to the disadvantages of using wind power as a source of energy. So the first disadvantage of using wind power as a source of energy is noise and aesthetics. So there is no denying that wind turbines produce noise, and if you live near them, this may be a problem. The sound they produce can travel some estimate up to 2 km, but they are not noisier than a busy highway and are situated near populated areas. So the sound will also carry depending on the direction of the wind that day, and if there is no wind, there is no noise. Second disadvantage is impact on local wildlife. So there have not been enough studies to be sure, and figure for the US could be anywhere from 20,000 to more than 573,000 birds are killed every year. So by comparison, between 797 million and 5.29 billion birds are killed by domestic cats and other human activities, and the 599 million birds die by flying into building in the US alone. Third disadvantage is wind fluctuation. So another disadvantage of wind power is that wind is not constant. So in fact, it fluctuates both strength and direction. So today's technology, including computer control, it helps immeasurably, as does the sophistication shown in where-to-site wind turbines in farms. Fourth disadvantage is unreliable and unpredictable. So wind energy suffers from what is called intermittency. So it means it is a disruption caused by inconsistency of wind itself, since wind can blow at various speeds. So it hard to predict the amount of energy it can collect at a given time. So this means suppliers in cities need to have an energy reserve or alternative sources of power in case of wind die for a longer length of time. Fifth disadvantage is wind can have a higher upfront investment cost. So despite wind power continuously dropping in prices as it gains popularity, it has to still compete with the lowest cost sources of electricity currently being used. So the operating cost of wind power has decreased 80% since 1980, and we can expect to continue to drop. So despite this drop, wind as a renewable energy source must still compete economically with non-renewable energy sources. Sixth disadvantage is wind turbines could lead to noise and visual pollution. So wind turbines can be a total complete pain to install and deal with the vertical bases. So wind turbines make a sound that can be between 50 and 60 decibels. So if you have to put it next to your home, some individuals believe that wind turbines are ugly, so your neighbors may also complain about them. Seventh disadvantage is safety of people at risk. So severe storms and high winds can cause damage to the blades of the wind turbines. So the malfunctioned blade can be safety hazard to the people working nearby. So it may fall on them, causing lifetime physical disabilities or even death in certain cases. So the last disadvantage of using wind power as source of energy is shadow flicker. So shadow flicker occurs when the blades of the rotor cast a shadow as they turn. Research has shown the worst case conditions would affect, by the way of light alteration, neighboring residents a total of 100 minutes per year, so the only 20 minutes per year under normal circumstances. So designers of the wind farms avoid placing turbines in a location where shadow flicker would be a problem for any significant amount of time. That's all, thank you.
I hope that you learned from our presentation about wind power. We also include a page of definition of terms for unfamiliar words that is included in our presentation. Let me read this to you. Renewable. Renewable means a source of energy that is not depleted by use, such as water, wind, or solar power. Decarbonization means the reduction of carbon, precisely meant as the conversion to an economic system that sustainably reduce and compensate the emissions of carbon dioxide. The third is aerodynamic forces, means are computed using distributed forces at each station along the vehicle, which can accommodate the variation in angle of attack at different stations and allows the proper calculation and of inputs to the flexible modes. Rotor means the rotating assembly in a turbine, especially a wind turbine. Generator means a device that converts motive power or mechanical energy into electrical power for use in an external circuit. Mechanical energy means the sum of the kinetic energy or energy of motion and the potential energy or energy stored in a system by reason of the position of its part. And the last one is transformer substation. Means is a location where electric power is converted from bulk power to local power or vice versa. These drop gauge stations sit at the center of many electrical wires, both above and below ground. They generally contain various pieces of electrical equipment and enclosed system. That is the list of unfamiliar words in our presentation. We also input here the references of our source of information about wind power. You can search it by yourself. Study it by yourself if you want to know more about wind power. Hoping that you learned from our presentation this afternoon. Have a nice day, everyone. Thank you so much.